The bowling ball has undergone a lot of changes over several centuries to become such a striking success. From a crude stone to carved wood to rubber to molded polyester, it's been reinvented numerous times. But the latest version has turned out to be a real winner. Technological advances have reshaped the bowling ball at its very core. No longer round, the nucleus is asymmetrical, which causes the ball to curve towards the pins as it rolls down the lane. They make the cores from polyester resin, blending in minerals like barytes, silica powder, and limestone. The result looks like chocolate milk, or make that hot chocolate, because a catalyst triggers a chemical reaction that heats it up. As they pipe it into the molds, it quickly starts to cure and solidify. In just 2 minutes, it's ready to extract. This core is oblong, flat on one side with a knob. There are different versions of this core design, each one carefully calculated to manipulate the bowling ball's performance at a specific skill level. They now drill towards the center of the core to make a pinhole. This allows the core to be suspended in just the right position in a second mold. This asymmetrical core is about to be encased in a more uniform sphere. They tamp the core into the bottom part of the mold and then lock down the top half. After all, they don't want any leaks as they pump it full of plastic. It's a liquid polymer blend. A special chemical in it causes the mix to solidify slowly. It can take days for it to harden around the core, depending on the formulation and type of bowling ball being made. When they knock it out of the mold, all is revealed. That asymmetrical core is now sealed in a very symmetrical polymer shell. Next, it's into a third mold. This one will seal the bowling ball in an outer skin called the veneer. This veneer has been scientifically formulated to enhance the ball's traction as it hooks towards the bowling pins. It's made of colorant, plasticizer, a chemical called ISO, and urethane. Blending these ingredients produces high-performance polyurethane. As the mix flows into the molds, a chemical reaction causes it to heat up and solidify in just seconds. Then it's into an oven to boost the chemical reaction. Next, a spinning grinder shaves off the bump which was formed by overflow at the mold's intake tube. The removal of this bump rounds off the shape of the bowling ball. With its 3 layers, this bowling ball looks a bit like a big bonbon when it's sliced in 2. And while it may look sweet, it needs a bit more work before it's ready to take on the competition. A lift system delivers the bowling ball to a sanding operation, which roughs up the surface. The coarseness of the sanding varies, depending on the performance goals of the particular ball. This machine heat stamps trademark information onto the ball. They do one last sanding as a constant flow of water removes the powdery residue. The more polished the surface, the less pronounced the ball's hooking action will be. Even this last sanding is geared to a certain performance standard. Once they buff the surface, all that's left is to custom drill the finger holes. With this bowling ball in hand, success should be within striking distance.
Modern bathtubs look nothing like tubs of the Middle Ages or those wooden tubs we see in Western films. To achieve supreme comfort, the designer explores new shapes via computer and design software, tools which make for speedy review of various shapes. Then a model is produced. This one, produced on a 1/6 scale, is made of cardboard, but other models can be made of clay, polystyrene, or by stereolithography. Manufacturing begins with an acrylic sheet. It is heated to about 200 degrees centigrade with ceramic elements. The sheet becomes soft and malleable. So that it takes the form of the mold, thousands of tiny holes in the shell suction the sheet by vacuum. The mold must cool before it can be opened. Powerful ventilators blow air directly onto the mold, lowering the temperature to 77 degrees in 4 to 6 minutes. The ventilators are then withdrawn. Then the shell is easily removed from the mold, and that's because it weighs a mere 16 kilos. To make a tub in another shape, they change the mold. They put it in another acrylic sheet. It is heated on the ceramic and fiberglass mold. The little holes vacuum out air, and the job is done. At any rate, the molded acrylic sheet is not sturdy enough to be filled with water, so it must be reinforced with fiberglass. This is the fiberglass. Mixed with resin, it is blown onto the mold by a robotic unit. Stored in reservoirs, the resin is carried to the robot by pumps. Here it produces a chemical reaction between the fiberglass and the resin, which produces a reinforced shell. Laminating is one of the most important steps. With brush and roller, they eliminate all air bubbles which could weaken the tub. This makes the fiberglass resin adhere perfectly to the acrylic shell. The process requires 75 minutes. The shell is then transported to the milling department. The shell is now dry and hard. They can extract it manually, but here they use digitally controlled machines. The operation begins with the trimming of the edges of the bathtub. During this operation, the robot will also pierce openings for the drains, the whirlpool jets and the air jets, for the overflow as well as for ambiance light. The bathtub, almost completed, is now sent to another workshop. They can now install the pump, the piping, and the blower. These last operations are done manually. The pump is installed for the whirlpool system as well as the PVC pipes, whose joints have been hermetically sealed to prevent any leaks. Finally, to make sure that everything is functioning well, each bathtub undergoes a water test. Some 13 steps have elapsed, plus 3 to 5 hours of work depending on the tub being made. It almost invites you to climb in.